So for section 3.5, geometry applications and solving formulas, I've got a lot of stuff here already pre-written where you guys can pause and write this stuff down. There's just some formulas here that you may or may not find helpful. You don't have to write them all down, but you know, just when it comes to geometric formulas, you know, we're going to be doing a little bit of geometry in this class, but the geometry is only going to be kind of algebra based. So just kind of how to apply it to formulas and find different parts that are perhaps missing, like the height or the width of something or both. So because a lot of times, you know, in regular geometry, our goal is to find just the area or just find the perimeter or the volume. So these we're going to kind of approach in an algebraic way. So the first example here, like I said, you want to write all this down. The first example, number one is just us getting used to how to work out a formula, you know. So we've got the volume of a pyramid, and that's the formula for volume of a pyramid. Volume equals 1/3 times A, and there's a capital A. What that represents there, hopefully, not that I want to make a big deal about this, but the capital A represents the area of the base. Sometimes they don't want to write all that out, so they'll write this capital A, you know. So that's what that represents. So if it's a pyramid, you know, the base might look like, it might be a square, it might look like a parallelogram because I'm drawing it at an angle, but you know, here's what a pyramid kind of looks like, right? A rough sketch of what it looks like. And so this is obviously that's the base, a rectangular base or a square base. Sometimes it could be triangular, could be any, really can be any shape. Typically it's square or rectangle. So that's what we're going to do. So it says if V volume equals 60, find A when H, the height, is 9. So the height of this, you know, we're talking about the very tip top to the middle of it. What is it? So we're just going to put all this in. So we've got 60 equals 1/3 times the area of the base. Area of the base we don't know, so I'm going to do times A times 9. Okay, and then the first thing I'm going to attack in this problem is just to undo that fraction. And to undo a fraction is a matter of multiplying both sides by 3 by the denominator, because that's going to get rid of that denominator. Oops, let me scratch that off. And I'm going to rewrite it. So now we have a new problem, essentially. 180 equals, and now we have an A and we have a 9, but I'm just going to write 9A instead of A times 9. And now just divide both sides by 9. And 180 divided by 9 is 20. So that's the area of the base. So the area of the base is 20 square units. All right. For the next part, we got steps for solving problems using formulas from geometry. And you know, for a lot of these, sometimes drawing a picture helps. You can write that down if you want. But yeah, I mean, just sometimes seeing it doesn't hurt, you know, just being able to see it. So we've got on number 2, it says the area of a rectangular garden is 105 square feet. Find the length if the width is 7. This one's pretty straightforward. And I'm just going to draw a rectangle. And keep in mind that your drawings might not be to scale. You know, you might end up having a longer part where it should be shorter or whatever. Don't worry about that. I mean, fall back on your math and your algebra and make sure that's right. But you're not always going to draw these to scale, which I sometimes do. So the area equals 105 square feet. And find the length. We don't know what the length is if the width is 7. That's it. And so area of a rectangle is a pretty simple formula, which is just length times width. So width times length is also the same thing. So that's how I'm going to set it up. So 7 times L equals area, 105. And then just divide by 7. Divide by 7. Those go away. And 105 divided by 7 is 15. And that's going to be 15 feet. All right, number 3, Mary is putting a wallpaper border at the top of the walls of her baby's rectangular room. And let me just stop there for a second. Now, this one's referring to a border, and this is not, it's not an area problem. A border is inferring that this is perimeter. So we're talking about the perimeter of the wall, around the room, around the edges of the wall of the room. Okay, so the width of the room is 2 feet less than the length. Okay, so I'm just gonna draw another rectangle here again. And let's say the length is L. The length is L, and it says the width is 2 feet less than the length. So we're going to do L minus 2. So L minus 2. And it says that the perimeter of it is 52 feet because that's how much she needs. So 52. Now, when you do perimeter, there's a couple different ways. You can kind of attack perimeter, and we could just identify, well, opposite sides are going to be the same. So if this is L, that's also going to be L for length. This is L minus 2. Well, the opposite side is also going to be L minus 2. But no matter how you look at it, perimeter is the sum of all the sides of that rectangle, of whatever polygon we're looking at. In this case, it's a rectangle. All right, so there's a couple different ways you can do this. My favorite way to kind of do perimeter questions is just double the length, the sum of the length and the width. So that's what I'm going to do. I'm going to do 2 times L plus L minus 2. And then I'm going to make that equal to the perimeter. So that's going to be 2 times 2L minus 2. 2 times 2L is 4L. 2 times 2 is 4. 2. I'm going to add 4 to both sides. Add 4 to both sides. And so we got L equals, 4L equals 48. Divide by 4. Divide by 4. And you get the length is 12. So right there, the length is 12, and that means the width has to be 10, because it's a matter of doing 12 minus 2. That's it. All right, I wrote some notes in here as well for steps for solving problems involving angle measures. And now I just kind of wrote down some important things, like, for instance, a triangle. It's good to know that all the angles of a triangle, no matter what kind of triangle it is, the 3 vertices of a triangle, they make up angles, and those 3 angles will always equal 180. They will always add up to 180. It doesn't matter what kind of triangle it is, as long as it's a triangle with 3 sides, scalene, isosceles, equilateral, obtuse, acute, right. No matter what kind of triangle it is, it's always going to be 180 degrees. Those 3 angles will add up to 180 degrees. All right, and I have something there about complementary angles. Now, complementary angles are angles that add up to 90 degrees. Supplementary are angles that add up to 180. And then another thing too, vertical angles are angles that are equal to each other. Now, vertical angles don't equal 90, necessarily. They don't equal 180 necessarily. They could, but they don't have to. The thing that is important about vertical angles is that they're equal to one another. They're exactly the same. So vertical angles are angles that are directly across from each other. That's what they are. So like right here, this angle and this angle right here are directly opposite each other, and they share a vertex. That's why they're called vertical. It has nothing to do with up and down. They share a vertex, and those angle measurements are exactly the same. So for instance, I'm just making this up. But if this is 51 degrees, so is this. Okay, that's how easy vertical angles are. If you can identify them and have one angle, then you know what the other one is. So for number 4, we've got a triangle. We have one angle given, which is 59 degrees, and we have two angles that are not given directly, but instead we're given an expression. And so we have 59 degrees right there. And if I do 180, we do 180 minus 59. 180 minus 59, you're going to subtract, and that's going to be 1, and then you get 121. Right here, what we're saying, or what I'm saying, is that this angle plus this angle should add up to 121, because we have 121 degrees left over, right? We have 121 degrees because we already have 59 degrees accounted for. So those two angles right here, this plus this, should add up to 121. So that's what I'm going to do. I'm going to make an equation using those two expressions and make it equal to 121. That's it. And then the x's make 13x. The constants make 4. Subtract 4 from both sides. And then 121 minus 4 is 117. 117 and divide by 13. Those cancel. And then 113 divided by, or 117 divided by 13. 117 divided by 13 is 9. It is 9. So we found 9. We found 9. And that isn't necessarily an angle in this problem. That's what we got for x. Let's look back at the question. The question says find the missing angle measures. So we didn't find the angle measure. X is not the angle. X is x. So now we're going to put that in. We're going to put that in for x. So we're going to do for this one, we're going to do 9 times 9 minus 3. Okay, so 9 times 9 is 81. 81 minus 3 is 78. So that angle right there is 78. And we'll do the same thing. We'll put a 9 in there. So we got 4 times 9 plus 7. 4 times 9 is 36. 36 plus 7 is going to be, is going to be 42. And there's your 3 angles now. If you want to test that out, add them all up. 59 plus 78, right? Plus 42, all 3 of those angles should add up to 180 degrees. If they don't, something's up with your math. All right, for number 5, what we have here, those are called vertical angles. Remember, vertical angle has nothing to do with up and down. It has to do with the vertex, the point where they meet, where those angles meet. They share a vertex and they're directly across from each other. All right. And the most important thing you got to remember about vertical angles is that they're equal to each other. They're not equal to 90. They're not equal to 100. They're not equal to 180 necessarily. They're equal to each other. They're equal to each other. So that is how we're going to set up our equation. We're going to set up the equation so that one angle, one expression equals the other. Because we're looking for x. And just like we did in the last problem, x is going to help us figure out what the angles are once we put it in. So let's get the x's on one side. We take away 3x from both sides. And 4x minus 3x is just x. Oops, sorry. So you got x minus 12 equals 7. Add 12 to both sides. 7 plus 12, those cancel. And x equals 19. So that's what x is, but that's not what the angle is. The angle is going to be a matter of putting 19 in for x. That is what we want to do. So we're going to do 4 times 19 minus 12. 4 times 19. Well, 4 times 20 is 80, right? So that's going to be, what's that going to be? 76. So you're going to have 76 minus 12, which is 64. So this angle right here is 64 degrees, right here. Okay. And if we did this right, the other angle should be 64. So as a good measure here, let's put in 19 for that one as well. So we're going to do 3 times 19 plus 7. Now 3 plus 19, or I mean 3 times 19, I should say. 3 times 19 is 57. 57. So now we got 57 plus 7, which, oh, by God, it's 64. There they go. They're both exactly the same. So 64 and 64. So that's confirmation right there. Got that right. For number 6, we've got supplementary angles there. And what we know about supplementary angles is that they add up to 180. Supplementary angles are a linear pair, you know, together, they form a straight angle. You know, they form a line, you know, together. That's why they're supplementary. That's why they're 180. So our equation is going to be pretty straightforward. We're going to do 6x plus 3x, and then we're going to make it equal to the angle measurement, which is 180. 3x and 6x makes 9x, and then divide by 9. Divide by 9. And now you have it. So x equals 20. X equals 20. Remember again, that's what x is. That's not what the angle is. That's what x is. Unless one of the angles is x. But that's not the case here. So we're going to do, for this one, we're going to do 6 times 20. 6 times 20 is 120 degrees. And for the other angle, we're going to do 3 times 20, which is 60. And 120 plus 60 is 180. All right, now I've already talked about complementary and supplementary, so I'm just going to go right to these examples here. Find the supplement of a 38-degree angle. I don't know why that's underlined. I think the word A is it's not spelled right. That's weird. I don't understand sometimes why things are there where they are. But find the supplement of a 38-degree angle. So that just means what plus 38, what number plus 38 makes 180. So x plus 38 equals 180. Subtract 38 from both sides. Those go away, and now we have it. X equals 142 degrees. All right, number 8 is a little bit weird. All right, but I'm just going to draw this out because it talks about complementary and it talks about supplementary angles in the same problem. Okay, so like for instance, like if this is x, if that's x, okay, this is going to be 90 minus x. That's the complement. The complement of it is going to be the difference of 90 and x. All right, if we're talking about vertical angles, never mind the scale here. I'm just drawing these just so we can get an idea of supplements. And then right here, we've got, if this is x, this is going to be 180 minus x. Okay. So that's how you want to set it up. So now let's read through the problem. It says 3 times the complement of an angle. 3 times the complement of an angle. Okay, well, that means 3, that's the complement right there. That's the complement. So 3 times 90 minus x is, that means equals 68 more than, I'm going to hold on to that for a second, 68 more than, because it's got that word then in it, which tells us that we should put that after. And then the supplement of an angle, well, that's the supplement of the angle right there. So I'm going to do 180 minus x plus 68. Now, if you put that in parentheses or not, it doesn't make a difference, because we're just adding 68 to it. So nothing's being distributed into it. I'm going to clear parentheses here. And you know what I'm going to do here? I'm just going to go ahead and put like terms together. 180 and 68 makes 148. So I'm going to put 1 minus x. Oops, and that's 248. Get the x's on one side of the equation. So we got 270 equals 2x plus 248. Subtract 200, it's a two-step equation. So subtract 248 from both sides. And that makes 22. I'm going to rewrite it over here. So you got 2x equals 22. And I'm writing it kind of in a different order here, but it should make a difference. Divide by 2 and you get 11. Get 11. So x equals 11. Okay, so find the angle. That's what the angle was. The angle is 11. So that's because x is 11. All right, the supplement of an angle. All right, supplement of an angle where we've already discovered that that is 180 minus x. Is twice the measure, is means equals twice the measure of the angle. So 2 times x. And I'm just going to get the x's on one side. I'm going to add 1x to both sides. Let's cancel it, then just rewrite it. We got 180 equals 3x. And divide by 3. Let's cancel, and x equals 60. Okay, now the notes just kind of jump right into something kind of completely different here. But what these are called these are called literal equations. That's what the proper name is of it. I'm not sure why they're called literal. I mean, I know what the word literal means, but I'm not sure why they're called literal equations. They just have that name. And what you're doing for literal equations is it says solve for the indicated variable. And that's in some respects, this is pretty abstract. But all we have to do is we have to get the variable that's indicated by itself. Okay, so for number 10, we want to get x all by itself. Okay, for number 12, we want to get t all by itself. We want everything else to move, you know, and when we move things, we're not literally just going to take, okay, I'm going to take this and place it over here. When we move things, we've got to use the proper conventions of algebra, the rules of inverse operations. We've got to use those the right way. We can't just take something and go, hey, put it over here. And sometimes it seems like it's almost easy as doing that, but we really have to make sure we're following algebraic rules. Okay, and so whatever it says, we want to get that by itself. All right, so number 10 is more like just a typical everyday equation. We're going to subtract 9 from both sides. Rewrite it. Divide by 2. There you have x. So x equals 4. Number 11, we want to get t by itself. We want to get t by itself. So we got a fraction in there. And one way to kind of deal with fractions is to multiply by the denominator. So that is what we'll do first, which is multiply both sides by 2. Sorry, it's a little messy here. So I'm gonna, now these cancel out right there. So now I'm gonna rewrite it. Now we have 2y equals tn squared. Okay. And yes, we just got to get now we have to move, and we have to move that term. Okay. Now we have to move that term the right way. So that's attached to that t via multiplication. And so if we want to undo that, we want to divide. So we're going to divide both sides by n squared. Okay, never mind that n is squared. We're just moving terms and variables around and stuff. So there it is. Now these cancel, those cancel, and we're all finished. We're all finished with it. So t equals 2y over n squared divided by n squared. Number 11, we're solving for x. Number 11 is very much like number 9, or number 10, I should say. Number 10, because except for the fact we don't have any numbers in there. We just have letters, but we're going to move everything around just like we did on number 10. Okay. So for number 10, we want to get x by itself. And so it's very important that you do these steps the right order. Order does matter in the way you do order of operation or inverse operations. So let's go ahead and take away c from both sides. Those cancel out. Now m minus c aren't like terms, so you just kind of have to just kind of put them together in a way. So we're just going to rewrite it. So we've got k equals m minus c. Oops, I didn't mean that. Let me write that again. Kx, I should say, equals m minus c. And we've got to get that k by itself. So we're going to divide both sides, or we want to get the x by itself. So that is a matter of moving the k. So we're going to move the k. We're going to divide both sides by k like that. Or you could just do like this. You can just divide the entire side by k. But the important thing is that that k is affecting the m and the c, not just the m, not just the c, both of them. All right, those cancel off, and now we're all through. So we have our literal equation: x equals m minus c over k. All right, number 13, one more literal equation here. For number 13, we're going to do kind of what we did before. We're going to get rid of that fraction. So multiply both sides by 4. Multiply the left side by 4, multiply the right side by 4. Those then cancel out. So now we're going to have, let's rewrite it. So now we got 4c equals, now this fraction was eliminated because we multiplied by 4. So all that's left there is n. A sub 1 plus a sub 2 is in parentheses, added up. All right, and our goal is to get a1 by itself. So if we want to get a1 by itself, let's go ahead and there's a couple different things we could do here, but I'm going to go ahead and let's distribute. Okay, let's distribute that. And that is a way to clear the parentheses out. So we're going to get 4c equals a1n plus a2n. Because, you know, a1 or a sub 1, you could say it like that. And now I'm going to move this term, that entire term over. We're not just moving the a squared over, we're not just moving the n over, we're moving a squared and n. So we're just moving the term, and there's a plus in front of it, so we're just going to do minus a2n. Okay, so those go away right there. So I'm going to rewrite it again. And we're almost there. Now we have one more step, and that is to move that n. We want to get rid of that n. And to get rid of that n, we're going to divide by n. And as far as we're concerned, we're all done.